Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for instantaneous decoding of the conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today we will go through the core concepts of GIS data types and GIS data models. What is meant by GIS data and its types? GIS data types includes that vector and raster models. Vector, which is a representation of points, lines, polygons, and raster, which is a grid-based representation, which have the objective is to represent the real-world features. So vector data is precise, while the raster data is continuous. So each type has its specific usage. That data format affects the accuracy of analysis and the precision work. So that data types are used in civil engineering for road networks, terrain analysis and land use mapping for the infrastructural development. So spatial data represents location based on the coordinates or the maps, while non-spatial data describes the attributes like name, type, population or description. So the objective for spatial or non-spatial data is to link location with descriptive information. So GIS works for the connection of both data types where a common identifier. So GIS plays the common identifier role for the same. Spatial data includes that the vector and raster formats. Non-spatial data is usually stored in the tables, that is the descriptive part. So civil engineers can use both for land records, for utility mapping and for project planning, etc. So in civil engineering, every piece of information that is important for the representation point of view or for the development point of view, from the coordinates of a bridge, pier to the elevation of any catchment area of a dam, must be stored in a digital format that the computer where we can use the data in future. Today we will explore the two primary ways that we model the world, that is raster model and vector model, to build a real world. The vector model and the raster model understand these differences is crucial for selecting the right data structure for your infrastructure project and ensuring accurate spatial analysis. Now, the vector data model, where points, lines and polygons are represented or used to represent. So vector model is based on the use of coordinates like x, y to represent the discrete features. Here we use the points for zero dimensional features like electric poles, boreholes. We use lines for one dimensional feature like pipelines, roads, rivers, and we can use the polygon for two dimensional areas like land parcels, land boundaries or building footprints. So in civil engineering, vector data model is preferred for tasks requiring high precision and legal definitions. So it allows us to maintain a clean topology or the topography, meaning the software understood, meaning the software easy to understand how features are connected, such as how a pipe connects a specific junction or a road connects to another road with respect to any intersection likewise. Next, the raster model, which is one of the type of data model. Just like the grid system, the raster model represents the world as a continuous surface divided into number of grid of square like cells or pixels. So each cell is assigned a specific value that represents a characteristics of that area, such as elevation, soil moisture, land use type, etc. So the size of the cell defines that the spatial resolution of the data, which is a smaller cell provide more detail but result much larger file size. So each cell we can take, or a number of cells we can take for the consideration, and that each cell provide more details but results is much larger file sizes. So it requires large storage to store the data. So in civil engineering we rely heavily on raster data model or raster data for remote sensing analysis, and digital elevation models, as it is the natural format for satellite and aerial imagery we can use. Cell resolution concept, which is one of the point which is most important for that raster and vector data types. So resolution in GIS and remote sensing defines the ground or the ground area represented by one raster cell, influencing mapping accuracy in civil engineering applications. So coarse grid, where low resolutions are there, uses larger cells like 10 by 10 in size, giving blocky shapes which low storage needs but poor spatial detail. So 10 by 10 size, large blocky shapes and poor details are there. On other hand, fine grid, where high resolution is there, uses smaller cells like 50 by 50, producing precise and detailed features with higher storage requirements. So low resolution coarse grid, high resolution fine grid, high resolutions large storage required, low resolutions low storage required. Vector topology concept. So vector topography, or we can say that topology. So geometry is shape, but topology is a relationship in between them, or we can relate to geometrical shape by using that topology. So vector topology in GIS represents spatial relationship between geographic features, where geometry defines shape and topology defines how features are connected or related in civil engineering mapping. So spaghetti model contains unorganized lines without nodes or intersections, making spatial relationship difficult to analyze and reducing efficiency in GIS based infrastructure planning. So spaghetti model is not easy to understand because there is not any node point or connection point or junction point or intersection point. So topological model organizes lines with connected nodes at intersections, which create a structured network that improves spatial accuracy and data management. So this is the actual difference in between spaghetti model and topological model. Topology function in GIS helps computer understand spatial relationship through the adjacency, connectivity, containment, likewise. So what is meant by adjacency? Which parcel is next to this one? Like question we can ask so that we get the answer of that adjacency, which parcel is next to this one, identifying the neighboring parcels or land features. What is meant by connectivity? Do these roads connect? Means we have to check whether roads, pipelines or drainage networks are connected. And in containment, determining whether one feature lies inside another or outside that line, such as island within a lake or island within a sea, likewise. So in civil engineering point of view, vector topology improves road network analysis, utility mapping, transportation planning, watershed studies and urban infrastructure management based on that remote sensing and GIS concept. So in last slide we see that node, here Node-Arc-Polygon structure is there. The nodes are at the corner points, arcs are between the two nodes, or arc is used to join the two nodes, and polygon is the area which is inside to that all nodes and arcs. So the arc node data structure ensures integrity, that no duplicate lines, that is shared boundaries stored once only. So there is no any duplicate line at that structure. Define left versus right polygons for every line. So each and every polygon with respect to direction we can mark left to right or right to left. And that arc node data structure enables network analysis, where shortest path we can monitor or get. So with respect to that structure, which is most easy or which is provide opportunity to civil engineer to mark the activity or to mark the node points or mark the ground control points easily for the reference. Next we have to take the storage. So data storage comparison, which is one of the point. Why data storage is required? Because raster data and vector data, raster model and vector model requires n number of inputs, just like the data collection. So data storage in GIS compares how raster and vector models store spatial information for remote sensing and civil engineering applications. So raster data model stores information in grid cells. Vector data model stores only feature coordinates. So in raster data model includes empty spaces resulting in high storage requirement and large file sizes. But in vector data model, points, lines, polygons are used for representation, which make it more compact and efficient for infrastructure and utility mapping. Here, run length encoding, which is a concept which use, or we can say that it reduces the raster storage by compressing repeated cell values, such as recording consecutive empty cells instead of storing each cell individually. So we can use that run length encoding for a single row or for a number of cells. So in civil engineering point of view, raster data is suitable for terrain satellite imagery and elevation analysis, while vector data is preferred for road pipelines, cadastral mapping, urban infrastructure management due to its storage efficiency and precision work. Here comparison in between the raster and vector on the basis of advantages and disadvantages. So what are the advantages and disadvantages of vector data? What are the advantages and disadvantages of raster data? So we will go for raster data firstly. So raster data is exceptionally efficient. Raster data is exceptionally efficient for mathematical modeling and spatial analysis, such as calculating the slope of terrain, performing weighted overlay for a site's suitability, just like in the catchment area or in the dam like structure. It is the best format, raster data is the best format for representing continuous variables that change gradually over space. That change gradually over space. It can appear pixelated when zoom in. It can appear pixelated where zoom in, and it is less efficient for storing discrete features. It is less efficient for storing discrete features like thin pipes or narrow property lines. In civil engineering point of view, raster data is the big picture tool used for environmental impact assessment and regional planning. Now, what are the advantages and disadvantages of vector data? So the primary advantage of vector data is its high spatial precision and small file size. So it requires less storage. It looks sharp at any zoom level, similar to a CAD file. It is also the best format for network analysis, such as calculating the shortest path for a fleet, calculating the shortest path for a journey of a construction vehicles from A location to B location, just like RMC plan to the construction site. So vector data is computationally complex when performing overlay operations, and it is not suited for continuous data like temperature or elevation or traffic density, etc. So for any engineer or any civil engineer point of view, vector is a tool for design, and it is used as a built documentation where exact boundaries are non-negotiable. Where exact boundaries are non-negotiable. Now, moving towards the summary from abstraction to action, the real world to the actionable data. Real world to the actionable data. So, GIS and remote sensing show the workflow where the real world is transformed into digital models, just like raster model or vector model, to convert the geographic information into actionable engineering data. We can use that actionable engineering data for our sake of interest or for our development of infrastructure point of view. Raster model represents spatial data using grid cells or pixels, and which is best suited for continuous features like elevation, temperature, land cover, density analysis. Vector model represents data using points, lines, polygon, which make it ideal for precise civil engineering features just like roads, boundaries, utilities, infrastructure networks. So from abstraction to action, GIS converts complex geographic conditions, or we can say that topology, into measurable and analyzable data. Supporting planning, design, and decision making processes are dependent on it. So, raster and vector models together support surveying, transportation planning, urban development, watershed analysis, watershed management, infrastructural management by turning geographic data into engineering solutions. So we can convert the real world 3D earth into the actionable data, just like we are the users. So we can control that whole earth with respect to the raster or vector for the development point of view or the engineering actionable process point of view. Stay tuned guys, happy learning.